Welcome everyone to the Test Guild and HCL software training session on API testing for Kubernetes, transparent remoting using HCL OneTest. Before we get into it, let's have our guild guests introduce themselves. So let's start with you, Martin.
So good morning, good afternoon, everyone. My name is Martin Lescuyer. I will be your presenter today for this session, and I am the HCL OneTest product manager. So I'm working with as an offering manager for HCL OneTest offering. In my career, I've been involved. I was involved in the development as an engineering development manager for mainly performance testing things. And I've moved to that new role for offering management for the overall OneTest offering.
Awesome. Great to have you. And Stuart?
Yeah. Hi, everyone. Stuart Walker. I'm a technical advisor here at HCL Software in our test automation group. I'm an API and integration tester by craft, but turn my hand to lots of different things. And yeah, very happy to be here today.
Awesome. So let's get into the training. Martin, it's all you.
Thank you very much, Joe. Thank you for this webinar that we're going to have together around. So yeah, API testing for Kubernetes. And what we're going to talk about is transparent remoting using HCL OneTest API. I was thinking before we do this deep dive into what exactly is behind testing for Kubernetes, what are the challenges that we are facing in this approach. We're thinking it would be interesting to have an overview about how the architectures have been evolving over the last years, over the last decade, before we do this deep dive. And so I forgot to say that I will be accompanied today by Stuart Walker, who will be doing this nice demo after this quick presentation of the features and this background. All right. So let's go a little bit back in the 90s, when basically the things we were working with, we were calling that computer was looking like something like this, sort of dirty, ugly, white plastic box. Not very friendly, actually, but that's we were doing things on those machines. Let's call that machines. Yes, what we were doing was basically some really monolithic applications. What we were doing there was like single executable, using very simple schemes, and everything was running on a single computer. Computers were not yet really well talking to each other, and our applications were talking to each other. And indeed, that was the decades where I started working. Yeah, so not that young. And I remember perfectly the noise that the keyboard, was doing when you were clicking those keys. I would say was doing so noisy, characteristic noise. And so, how was the testing at that time? The kind of applications we were developing was looking at something like this, sort of terminal applications. We were entering numbers, letters, keys, going down into menus and submenus, something like this. And in the end, probably we would be presenting a data screen, or we were also developing some algorithmic applications and all that sort of things. But testing was quite easy. You just had to sit in front of these machines, just launch it and try and verify that it was expecting as it was behaving as expected. At that time, we had no timeout issues, no connection refuse. We were not having any network. So yeah, the things were quite simple. No lab management indeed, because what you had to do is really sit in front of the machine hosting that application that you wanted to test in order to interact with this application. So it was quite easy. Testing was not really existing then. This V diagram appeared in the old project. And it was really the first time that the testing really got formalized as clear existing and costly activities, actually. But the thing with that V diagram, if you remember it, for some of you, we can remember it, you had to write tons of documents and tons of documents really before starting to write the very first line of code. You had to collect the requirement, do all the system engineering, all the system split, all the component designs. And in the end, when eventually you would start the coding, in the most case, you would say that what has been designed is just not possible. So you had to go back to the person who did that design actually and say, hey, that's not possible to do what you've designed, make a change in the design, or and finally code again. And then when eventually you will be at the end of the coding stage, usually the project was over already, right? The date was over, the delay was not respected, and all that sort of thing. So testing were indeed existing, but in most cases, from what I've could seen, it was a disaster because it was saying, yeah, I just tested it, it works. I've applied this, but in most cases, the testing activity was not really happening as it should have been happening. And so what happened then happened, don't know, for some of you will remind this kind of really weird errors, errors on errors and all that sort of things. Applications were a bit looking like this. Currently, this is the optical fiber connection box, which is in my public building. I can say that it's a real nightmare and a real disaster. Well, applications were basically the same, right? We had to face reliability issue. We have to face, as I said, unexpected delays in project achievements. And the network appeared at this time. So the network started to communicate with each other and all that sort of things. Obviously, applications were not scalable, so there were some scalability issues. There was lots of issues like these ones, and people were getting distributed on different geos. So obviously, yeah, the machines has to talk to each other. And last but not least, when you have been writing something for a particular project and for a particular application, you say, I've done that already. So you would like to say, I can reuse this straightforward. So let's you could not do this because that component was fully integrated into the applications. It was not designed to be reusable from day one, right? So you cannot reuse anything. Basically, each applications you had to start it from zero every time. So things had to change, right? And in terms of change, the first thing that happened was modularization of those big blocks. So the applications began to be split into components. Shared component started to exist. So basically, you were able to have for example, some core components, some team working on core component that would be reusable from a project to another project for shared between projects. The shared libraries also began to be existing. And it was at that time that the client-server architecture started to exist. So instead of having a whole monolithic applications, clients were standing over the internet behind terminals, and so that deeply increased the performance and the scalability of the applications. Applications were able to react in parallel to different people in parallel and all that sort of things. How became testing with that? Applications, as we said, the complexity of those applications increased drastically. So you can imagine that the testing also became more and more complex and more complicated. But the systems were still open to be tested, so it was still very possible to write programs replacing that virtual user, for example, and write a program that would send messages over the net and trigger the server to make sure that it behaves as expected. There was no restriction. Continuing the journey over those architectures, they came from client server, evolved into what we called SOA architecture. We were back in early 2000, 2005, something like this, where the applications became fully distributed from client server. We moved to a server being a client of another server, and so on. And the applications were clearly service-oriented and message-oriented. So for a service, you had service consumer, service provider, and all those services were standing into registries that could be discovered and published there, and so on, all those kind of protocols. And applications were composed by a set of loosely coupled services. XML at that time was the standard way to represent data. It's still widely used over in the IT industry today. And web services was a standard way to communicate between those services. The business logic of applications is break down into different services in the applications, and it allows, the fact that they were loosely coupled. It allows the developers to modify a piece of the applications without unstabilizing the overall applications. So it was a good step forward. At that time, the services and their APIs, specifically their APIs, got formalized. At that time, we had WSDLs. We could describe APIs and in a machine consumable way. So that's important for the tooling that we were developing at that time. It became possible to develop automated testings and all that sort of things. About the V diagrams, it was also recognized that it was absolutely not possible to see everything and to predict everything in documents before starting anything, any spikes and any risk assessments and all that sort of thing. So the agile method was all about this. Instead of making everything from the beginning, we will have to iterate over humanly achievable piece of thing. We call that sprint one, and then we'll complexify the solution over the time with the sprint 2 and the sprint 3 different iterations subsequently. And so testing became much more part of each iteration, as we are going to see. With SOA, the testing became, as we said, the tooling took off because with machine consumable API descriptions, it became really possible to make some toolings around this, and so API testing took off on automations and all that sort of things. The system and the test still are open for testing and easy. It's sort of, you make a call, you make an HTTP request or something like this, and you hit the server. So that's sort of easy. And in terms of testing methodology, as we said, with the agile methodology, testing became part of strictly each iteration. And so it became much more a continuous process over the project. And now, whereas in the V diagrams, if you remember, we were not spending enough time because it was arriving late in the cycle and all that sort of things. Testing now is completely integrated in the overall development life cycle as we know today. So that's part of the evolutions of testing, fully integrated stage at each iteration. Where are we now? Continuing to split from monolithing to SOA, and now we're splitting into what we call microservices, which is some very little piece of things, doing very little functionalities, but put all those services together into a big application, so it's an easy maintenance. It's very scalable. It's very flexible. It's very reusable, and all that sort of things that we know. But how did that impacted the test? As you can see in this figure, the microservices are encapsulated. They are depending one of each other. So yeah, now it becomes really useful to have some API testing tool automation and service virtualization in order, for example, if you want to be able to test individual microservices, which is just in the middle of this picture, you definitely have to stub the dependencies and be able to replace the triggers that are in front of this microservice. And with the number of those microservices now existing in these such applications, some level of orchestration is definitely needed. And this was where Kubernetes appeared. We can talk microservices without Kubernetes. So Kubernetes is that sort of big piece of what we call a cluster. A cluster is hosting some nodes. Node is a sort of physical machine, node hosting pod, and pod hosting containers. And containers are hosting services. So it's run in a containerized way. So the runtime environment is fully isolated, and Kubernetes is very good at orchestrating all those containers in the cluster, right? So it is capable to start some new pod in case of higher demand. For example, when the performance of the system is going down, it is capable to start new pods on its own. On different nodes, it doesn't matter where exactly the pod started and all that sort of things. It's also capable to propagate updates into the applications quite smoothly. So the applications got sort of auto-updated. And no matter where the pods are, no matter where the containers are deployed on which pod and all that sort of things, it's really reliable. And the pods are running in an isolated way, and that's very secure. If a pod is crashing, it's just restarted by Kubernetes on its own. And so, in this containerized world, in this containerized world, it's very often very difficult to be able to be selective in the microservice that you want to test. Because if you look at what a typical Kubernetes application looks like today, it's looking like something like this. You have the cluster, and inside the cluster you have it's made of a number of containers and services within those containers, whether they are database services, whether they are resource monitoring service, or whether, for example, it's a reporting service. There is all sort of containers and services that are sits behind this cluster, behind this Kubernetes thing. And by default, the only way that users have to interact with what they are currently developing, which are their microservices, by default, the only way they have to interact is through the overall application API. Just like this, if this would be a house and the door is here and there is no other way to get into this house other than going through this door. And so all the API interactions that you have that we have to do with those internal services is going through this ingress controller, which typically is there in Kubernetes environment. Call that egress controller, or we can call that a gateway, it doesn't matter. But anything that enters into the cluster is going through this sort of man in the middle, right? So this man in the middle is, you've got that thing that is, orchestrating the request that you send and the result that you get when you are outside of this house. as a client, for example. So yeah, you have to go through this API, and that might be okay if you consider that this is an application, this is my application, and this is a black box. And it's very, very possible to test this as a black box using this API, and that's it. It's okay. But that might not be sufficient if you want to, for example, if you have, for example, a third-party server, for example, which is outside of the cluster, and you want this third party to, for example, a Grafana server that you would want to connect to one of your internal services, which would be reporting services, like this. You would like him to collect some data, pull some data to make some nice dashboard, for example. In this case, this link is not possible. The system has to go through the door of the server has to go through the door of the system, and all the requests are going through this ingress controller and maybe going through a number of pods in between before finally going to that reporting services. And that's not what you want to do. And for example, also with OneTest, what you can do is write a test at the browser level, at the UI level, so you can use a browser, fill some data into a form. You are a new customer on a website, on a commerce website, for example, and you click submit, and it submits a request to the system that get into this ingress controller and that go through all the pods, and in the end, very probably it gets written into one of these services, which is a database service. And part of the value of OneTest API is to be able to write another test at the API level, connect with this API service, and say, I would just want to verify that the data that I sent to the browser is actually the same that has been written into this database, and I want to make sure that the writing into the database happened properly. And the issue with Kubernetes is that you just cannot do that because you have to go through this API and you just cannot get connected directly to the database. This is all what transparent remoting is about, right? Transparent remoting allows user to provide the Kubernetes configuration to OneTest API such that it can then address individual service directly in the cluster. So now, rather than going through this gateway, rather than going through this controller, you can directly interact with the services directly, ignoring any intermediary service that would normally be there if the user is standing outside. So if I do that number, I can test my microservice in isolation, just as this would not be inside a cluster. It would be a discrete component. So we are making this transparent. We are making the remote Kubernetes service transparent to us, so we can make that individual testing, right? So if you have a Kubernetes-based applications, and if you want to test a particular service inside the Kubernetes cluster, then transparent remoting is how you would be able to do that. Because with OneTest, you would be able to directly establish a link between OneTest API and this service. Right. And so the only information that is needed for OneTest API to be able to do this is this Kubernetes configuration information that needs to be provided to OneTest API. With this information, OneTest API is able to do things inside the cluster, but actually won't change anything inside the cluster. And there is absolutely no way the user is required to change anything in the cluster. So just give the permission, and OneTest API would be able to connect to any of these without changing the cluster. And then once this connectivity is established with between OneTest API and the cluster, you can do all what you already do with OneTest API. So for example, you can import OpenAPI specification from those services, which is very typical way to describe microservice APIs, and import this into the tool. And with a couple of clicks, you can learn everything about all those endpoints and do tests for them. So, and trigger those endpoints very easily can run this in a couple of clicks, as we'll see during this demo.
Okay, thanks, Martin. So, following along from Martin's presentation, we're going to go on a bit of a journey with the demo. We perhaps won't go quite as far back as some of the early renderings that Martin showed, but we'll certainly go back and look at some more traditional landscapes, as well as getting to our modern cloud native landscape, where we're going to look at the transparent remoting. And the reason for doing this is to look at both ends of the spectrum. Nobody in any sort of size of organization is going to have one architecture alone. You're very likely to be working with applications that look like this, quite old, perhaps traditional architectures that have very traditional multi-tier topologies. In this case, we've modeled a holiday booking platform, vacation booking we've called it, and it has multiple tiers supporting the front end, middle tier transformations, data storage, data enrichment, and so on. As you can see on this slide, it's a nest of lines going from one place to another, and all of these lines correspond to an API that potentially has a different type of schema or a different type of interface. So we're going to start by looking at this and understanding how we could go about testing that. And one of the biggest challenges of testing an application that is potentially a decade or more old is understanding how it's hanging together. In my case, I have a wonderful diagram that shows me all of these interfaces, but what this doesn't tell me is how is this data actually going from point A to point B. I might have to look in the code to find the endpoint. I might have to look in source to find out the data format and the expectation. There may not be schemas, and there may not be documentation even as good as this. So we'll start, as a lot of our testers with OneTest do, by using service discovery. And this is a means through which we can discover how an application is communicating across those multiple tiers. And I've pre-instrumented my environment with some intercepts that allow us to capture traffic as it's flowing through this small demonstration system. And if I use it by trying to book a specific flight, here I'm going from London to Barcelona, I'm looking to book a hotel, and I'll just quickly pre-fill these form details so I can process an order. We'll see that it confirms my booking, gives me a reservation number, and as any good tester might think in terms of how to test this particular transaction, I'm going to go to the database, the only way I probably have access, which is through a user interface, and I'm going to just check that my transaction, my booking for this particular flight has been persisted in our database. It is in the right state. It's there. Our transaction is complete. So I've just flowed through a very simple user business flow, and what's happened while we were doing that is we've captured or discovered the services that were invoked by the various parts of that application. So we can see here that we've captured some MQ traffic across a range of different queues. We've captured some JDBC invocations to a database called vBooking, and we've captured a bunch of HTTP traffic. And I happen to know that I'm working with the hotel service. So we're going to take these three things, MQ, JDBC, and HTTP, and we're going to take them from our service discovery and move them into our modeling environment. I correct that because it'll annoy me otherwise. Now, what that's done for us is it's modeled those different endpoints so that we can start thinking about testing them. Or if we want to, we can actually start thinking about recording traffic through those interfaces and actually extracting data from the live system or the test system to create interface tests for. Now, the service discovery has automatically set up things like my connection to an MQ server. It's extracted that from what it discovered. It knows what endpoint's being accessed over HTTP, but what it can't do is capture credentials. So, for example, for my database, I am going to need to manually put in the username and password. But because this database resides in my environment, it's a very traditional environment, I have no trouble whatsoever reaching this VB database. I can make a connection, and we can go on and create our tests. We'll see later how that's a little bit more challenging when it comes to working with a cloud native app. So as I said, what we'll do next, having discovered these services, is we'll start to record some traffic from them. And here in what we call the recording studio, I'm instructing which interfaces I'd like to record, setting up the recording, and then we'll go back to our user interface and we'll flow through another transaction. We'll make a booking, first of all, retrieving some flight information and retrieving some hotel information, choosing a flight that we want to book, selecting a passenger that we want to book onto that flight, hitting proceed, and then once we've got our reservation number ending in 75, we'll go and just refresh our administrative console that queries the database, check that we've got our booking, and we'll jump back into OneTest API where we can now see all of that traffic that we've recorded. So the first thing we recorded was a call to the hotel finding service, and as Martin said, XML is a very common data format, and here we can see there's actually an XML, or in this case a SOAP envelope, querying for hotels in the city of Barcelona on a given date and getting a response with some different hotels, the Downtown and the Global and the Superior Hotel. We can then see a call to go and book that hotel with all of the information about the passenger and the hotel name and everything else in there. We can see there's a query to the MQ service. And I can tell that's MQ by looking at the headers and observing which operation it is I'm working with here. Again, we can see the information present in that booking. We've booked a flight for Ling Wong on flight VB232. And we then see we get a response telling us we've successfully booked our flight. Here's your reservation number. And then last but not least, we've performed a query into the database to retrieve all rows, because that's what that administrative console did. And we can see the result set of data, or a snapshot of that result set of data. So that's really insightful for me as a tester. It allows me to understand what's going on in the system, what I might like to test. It gives me some data to create some basic tests from. May not be the only data I'll need, but it'll certainly be a good starting point. And what it then allows me to do is to create a test. So I could create individual tests for each of these services, or what I'll show you now is how we can build a test across all of them as a simple integration test, and I'll call it such. And what you'll see is that this then models exactly what we recorded. So we have a request for a hotel finding service, a request for the booking, a request for the flight booking, and then a query to simulate what we did in the UI to the database to get back our flights. So we'll run that test and observe something that's potentially a little bit unique to OneTest, and that is that we're quite strict. We're very hard in that when you record something or when you provide some data to the tool, we will validate it as an expected set of data. So if in our case we recorded a query to the flight booking system, and we recorded a success and a reservation number ending in 00075, well, that's now encoded into my test. Over here, there is an assertion already present to look for that A00075, and therefore when we ran the test failed because we didn't get reservation A00075, we got A00076. And we can even see that if we click on the error, we can see that in a message difference perspective. So over here on the left, expected 75, over here on the right, got 76. And we do this intentionally to try and encourage people to apply assertions rather than simply just looking for, did we get a 200 okay? And certainly not expecting you to write code to achieve any of this. So in my context here, my test is failing, and I need to tune this validation, as we would say. So I could do something as simple as disable validation on this individual field, or I could ask the tool to provide a regular expression that would match both of these two values, so that next time if we have a different number, as we would expect, it's going to match for us. So we'll tune the test, we'll close and rerun, and we'll let it go through again. But it's still not going to pass. We're going to expect another failure. And this time, the failure is because when we built the test, we did a select all on our database table. That's what our administrative console did. But from a testing point of view, we're saying, well, we expected 75 rows. That was what we recorded. We actually received 77. So we need to do a small amount of work there just to tweak that. And to save myself a little bit of time, I've pre-written the query. So if we go into our select statement, what we'll do is say, actually what we want to do is check the flight number, where the reservation number is our current reservation number, the reservation number that we just made a booking for in this particular test case. So how do we get that reservation number? Well, again, you don't need to write code or anything complex. You simply go into a step of your test. In my case, it's a response over an MQQ. You look for the piece of data you're interested in, the reservation number, and we can store it. And that store action will store the reservation number into a variable for me, which I can then use here in my test. I can pre-populate my test with some data. What were we, 77, I think it was. And we can set that as our baseline assertion, so that when we run this, we're going to assert that there is a row with our reservation number and the flight number is VB232. And now if I execute that test, we've got a complete API integration test for quite a simple business workflow. Except one thing I missed, except that API tests, certainly in OneTest, are very rapid. But databases are not always as quick. So in other words, when I make my booking and I get back a response from the MQ booking service, there are multiple tiers of this application, and the data could still be working its way through to the database and isn't yet persisted. So what we need to think about is retrying perhaps every second for perhaps up to 5 seconds, to make sure that within that 5-second period, we do find a reservation with our reservation number on the flight VB232. And this time, indeed, we see we do. So that's a kind of a, how did we do API and integration testing for the last decade or more? And we, of course, still do it this way. There are very much lots of these types of systems around. Now let's have a look at how we would work, or how we do work, with something a bit more modern, a little bit more cloud native, and leaning into the architecture diagram that Martin showed earlier on. We have an application called Acme Online Retail. And Acme Online Retail is a very simple app. It's a React front end. It allows us to order products. I can have a silent alarm clock or a glass hammer, maybe some tartan paint. I can add them to a cart, and I can choose to have them delivered to a given address, and I can select which type of delivery I'd like. And this is a service that we'll come back to a little bit later. So maybe I'm an international customer and I'd like to place an order for tartan paint. And if I go and scroll down, I can see down here, here's my tartan paint order, $499.99, quite expensive. And my delivery estimate of 7 to 10 days. That's the kind of the basic premise of the application. How does it hang together from a topology perspective? Well, we have our React front end talking to our microservices through an ingress controller in Kubernetes. We have a couple of services for order processing and product inventory, but we also have in the back end a couple of databases and this shipping estimation service. And you'll notice that these are depicted behind the orders and products pods, because essentially they're inaccessible from the outside world. This React client and any other clients have no route through to those pods and those services. So we'll build 3 different tests to demonstrate how we would work with this cloud native application. And we'll start with a simple one. We'll start with working through a basic API for our orders service, the sort of thing that you might expose to a third-party application, or in my case, that's used by my React client, by that web front end. And so we'll go back to OneTest API, and we'll come into our modeling perspective. And this time we're not going to use service discovery. We're going to use, as Martin showed, a different approach wherein we will take the specification, which I'll copy from over here, and we'll load in the schema or the specification, open API spec in this case, from our service at acme.com. And because this is a public service, I don't need to do anything in order to synchronize it, to pull in that information. You'll see up here, we've retrieved the endpoint information, and we've retrieved information about the different services that are available, and also about the data formats and the structure of the messages, the requests and the responses. So without anything special, I can come into my testing perspective, and I can create a new test. And let's call it order 1. And I could construct a message to place an order. So here you'll see we're not dealing with XML anymore, we're dealing with JSON, and you'll see the basic mandatory parameters of what the schema defines as a request. More often than not, this isn't going to be enough. I'm actually going to need to add some optional or choice fields. So in my case, I probably need to add an item, and an item contains item description and name and price and stock and so on. And I could add other fields to this message, delivery estimates, or what I can do, partly to save us some time in the demo, but also because in the real world, this is what we do too, is I can simply say, here I have a sample message that I prepared earlier. Developer gave it to me, or I constructed it from some other means. And you'll see I've populated some values in accordance with this order process. You'll also see down at the bottom here, I've used one of our system variables, this %% notation that we used before, to indicate that we're going to insert a date. So with that, let's run the test. And again, we're going to see this test fail, but it's going to fail because we didn't set a correct assertion. We didn't say what the response was going to look like, and it doesn't look like the default schema response with only the mandatory fields. So we can see over here on the left, this is what the test was expecting, some basic parameters, and here's what we actually received. We had a 201 created, and we got that our order is in a status pending, and we can see what the order details were. So in this case, we're going to do an overwrite on our expected message. So we're going to set our baseline assertion so that next time around, we expect the same response. But if you're observant, you'll recognize that that's probably not enough from a tuning perspective in the validation. And actually, our order ID is incrementing from 30 to 31, and the date time is changing. So we need to do a little bit more work. And we're just, for simplicity's sake, going to say we'll disable validation on those 3 individual fields that you see now grayed out, but everything else is still being validated. There's no complex code. There's no writing complex JSON path or XPath or script. It's all done with a few clicks. And at this point, I can now run my test, and I've got a simple API test that will test I can place an order successfully. Now, just like we did with our more traditional app landscape, I want to go that one step further. I don't want to just acknowledge that this order service has put my order into a pending status. I want to make sure it is in a pending status so far as the database is concerned, because these other services are going to read state from the database. So this database is inaccessible to us from externally outside of the cluster, and therefore we need to start using our transparent remoting features to access it. So we'll do that once we get our database connection created. So we'll do that here. We'll add a database server for our orders DB. And once again, I'm going to save us some time by using copy and paste. Here we go. In my case, I'm using a MySQL database. And if I test the connection to this database, because we're outside the cluster here with our Workbench client, and because we don't have that root, it's going to say, I can't connect, I can't communicate, I don't recognize any host with the name MySQL and the port 3306. What we need to do is to create a Kubernetes proxy that we can pass in to this database connection so that we can make that connection, tunnel that connection through. So we'll do that here in our physical view. I'll create a new Kubernetes cluster. And a Kubernetes cluster resource in OneTest API is essentially a set of credentials to allow you to access the cluster. So you can configure these manually if you will have the certificates and the keys and so on, or in most cases, most of us would already be working with the Kubernetes cluster, and we would have access to a kubeconfig file, as I have here. And this kubeconfig file contains all of the information necessary to access a particular context within your Kubernetes cluster. So by importing that, what I've done is I've given myself a way to connect, all thumbs and fingers. And if I test my connection, you'll see I can successfully establish a connection to this this host where my cluster resides. So now with that Kubernetes resource, we can add that as a proxy for our database connection. And this time around, if we test our connection, we're establishing a route through to that database within the cluster, and we are able to successfully make that connection. So now we can go back to our test, and we can augment this test case by saying, well, we'd like to not only place the order, but we'd like to then go to the database, or orders database in this case, and I'll just grab query. And again, we're going to parameterize this based on the ID of the response that comes back, the order that comes back. So we're going to say this ID field here is what we're interested in. We'll store that into a field called ID. And then in our database query, we'll simply again run that test. What was it? 29, I think was our order, wasn't it? So we'll run that again, and we can see, yeah, here's our pending status for order ID 29. We'll overwrite the expected result. And this time we're going to actually not just check for a static value pending. We're actually going to say, well, we're also looking for the ID, and we want the ID to be validated that it is the correct ID. This is not entirely necessary, but I thought I'd show you it just to make sure it's obvious that this is a feature. So there we go. We'll save that. We'll run our test, and now we've got an end-to-end test case that queries the API and then goes and checks through the back door, if you like, that our data is in the database. So that was test case number 2. The final test case number 3, is testing this shipping service, this microservice that is not intended for use outside the cluster. It is an internal service. Its primary purpose is to provide an estimate on how long it's going to take to ship a product to a given address. It's a very basic mock-up of such a service, but it serves that purpose. So again, we're going to go back to our architecture school. We're going to grab the schema, the Open API spec, and we're going to try to synchronize it. So in this case, we're going to the shipping service, and we're asking for the API doc, the YAML spec. And if I hit finish this time, it's going to say, well, hey, I can't do that because I don't recognize that host. There is no host with that particular name. So once again, we need to add our Kubernetes cluster resource as a means to proxy this connection. And if we hit finish this time, we'll see it can synchronize that schema. It can access the endpoint. The endpoint is already pre-configured with our proxy, Kubernetes proxy cluster. And we can see that there is a create shipping request operation. And just to round things out, we'll create a very quick test. To call that service, just to show there's no smoke and mirrors here. And we're going to say we'd like some international shipping, and we'd like to go to EC1 to AJ. And we'll run that test. It will fail, just like the other tests failed the first time through, but that's intended so that we can train the assertions correctly. And we see here, yeah, okay, we get an estimate of 7 to 10 days. That's what we would expect for our particular test case. We'll then close and rerun. And again, we've built an API test for that private service. So just jumping back through, what we did in the demonstration for the cloud native is we accessed a fairly vanilla API through the ingress controller without the use of transparent remoting. We then augmented that with a connection through the back door, if you like, into the orders database that otherwise would have been inaccessible to us from a tester perspective. And then we did something quite similar for a private, let's call it microservice, that has no route through the ingress controller. And we tunneled through in order to be able to test that using transparent remoting. So with that, I'll hand you back to Martin and Joe.
Thank you very much, Stuart, for this very nice demo where we've seen the transparent remoting in motion. Nice new feature being opening doors inside Kubernetes cluster. And thank you very much, Joe, for giving us the opportunity to make this demos and information. Thank you very much.
All right, so we did run a poll, and one of them was, where are you in your Kubernetes journey today? 62% said they're still investigating, 38% said they're in the initial stages, and 0 for fairly mature and 0 for old hat. Just wanted to know, is that something typically you see from customers you speak with, and any thoughts on this poll?
Yeah, I mean, from my perspective, Joe, I see all ends of the spectrum, very much, reflecting the numbers you've just shown. Perhaps, we do have customers that we work with who do work exclusively with Kubernetes. So, might have perhaps expected a few more in those categories. But yeah, all ends of the spectrum. Every organization is moving and transforming at their own pace, based on their own unique situation. And that's one of the reasons why I think OneTest is such a flexible application, because we're not purely a cloud native application testing tool. We're not purely a traditional testing tool. We're a bit of a Swiss Army knife, and that probably reflects the audience today, I think.
Great. A question we had is, as a tester, what permissions do I need in order to get access to individual services? And do I need to make any changes on the cluster? I believe you had that in the slide, but they may have missed this.
Yeah, I can take that one as well. So permissions wise, if you're working with Kubernetes, you'll already be working with the kubectl command line tools, the interface through which you can access Kubernetes, and through which you can make configuration changes, and so on. That connection typically from your machine into the cluster will use what's called a kubeconfig file. And that's a set of certificates and authentication credentials that allow you to connect to that cluster. That's exactly what we need in OneTest to allow us to connect and to create our transparent remote routes into the cluster. So there's no special configuration. There's no changes need to be made in the cluster or anything like that. If you already have access, or if you can be granted access to your cluster, then the kubeconfig file is essentially all you will need.
Great. Another question is, you showed HTTP in databases. I'm using Kafka. Does this work?
That's a good question. That's probably one I'll leave to Martin.
So not yet, actually. So yeah, that's very on our roadmap for the future. So the short answer is no, not yet, but yes, in the future, definitely yes.
It's definitely the kind of thing we've been asked. We've been asked about by customers. It's the natural next step, I think.
Nice. Awesome. So just a few more questions. One was, can I use this approach to performance test each individual microservice?
You want to take that one, Martin? Or?
So the answer is yes. This is definitely possible to add this OneTest API test inside what we call in OneTest performance schedule, and be able to run this test in a load within a load approach. So yeah, it is an option to use this transparent remoting feature that finally in the end it gives a connectivity. It solves a connectivity issue with something which is running inside the cluster. And once this issue is solved, basically you could do it's opened lots of doors, and including the performance testing things. Yes.
And someone asked about another user case. Can I use this approach to uncover Kubernetes tuning issues? I guess Kubernetes is known sometimes to have tuning issues for their application.
So if you can say yes, I can do some performance testing things. Very probably I can do some measurement and some resource monitoring. With this, you can get some Prometheus. You can collect some Prometheus, for example, metrics within this performance testing. So it can be used not to tune, but to monitor and get some inputs and get some insights about what's happening inside the cluster.
And last question, someone said, with the service discovery feature, how much SQL do I need to know? Does the application know what SQL to create and all the foreign keys and everything, or is that something that the tester would have to know?
So in the example I showed, we did two things. One, in the traditional app, we recorded a query into a database or an invocation, could be to a stored procedure or an insert. So the tester would receive that SQL and they would be able to replay it. But as you saw in my test, that's not always what you want to do from a test perspective. You don't always want to mirror exactly what the application did, because you're testing a specific condition. So there is some requirement for a little bit of SQL knowledge, but it's generally quite minimal. In the other case where we worked with a system and we didn't use recording to access it, there you would need to know, the basic constructs of a SQL query to extract the data that you need. But again, typically for a tester, we're not looking at massively complex queries. We're looking for quite specific data, not necessarily joining and doing anything massively complex.
All right. And so when someone goes to HCL1, there's a bunch of different categories: performance testing, API testing. When someone has HCL1, does that include this feature? Or is that a separate plugin or a separate license?
So HCL1 test is a bundle of different things, and the transparent remoting features comes up with HCL1 test API, and there is no specific licensing for this. There is no specific plugin, or it's included into the basic offering with HCL1 test API.
All right, guys, thank you so much for this awesome demo and awesome demonstration. And knowledge share. Thank you so much for joining us today at the Guild. Appreciate you.
Thank you very much.
Thank you, Joe.